Hi there. We're talking about hypothesis testing in statistics. And last time I tried to give you the big picture, introduce you to the basic ideas behind hypothesis testing. Now we're going to get into the details of actually working through all the steps of hypothesis testing problems. So in these next couple of sections, we're going to be testing claims about mu, that is, about the average or mean of some variable for some population. So the claim that we'll test is either that that average is some particular number, or the claim might be that the average, the mean, is different from some particular number, or that it's less than, or that it's greater than some particular number. But in any case, the claim is going to be about mu, either that mu equals some number, that mu does not equal some number, that mu is less than some number, or that mu is greater than some number. If we know the population standard deviation, we will be doing a z-test. That's section 8.2. If we don't know the population standard deviation, but only the standard deviation of the sample, then we'll do a t-test, and that will be section 8.3. And they will be similar. There's not a whole lot of difference between them, but it's kind of like when we were talking about confidence intervals. And we first did some where we were using the z sub alpha over 2, and then we did some where we had to use t sub alpha over 2 that we looked up on table F. And the difference there and here is whether or not you know the population standard deviation, in which case you can use z, or just the sample standard deviation, in which case you can use t. So at first, these first couple examples will be situations where we do have the population standard deviation, so we will be doing a z-test. Then later on, we'll move on to the t-test. So last time I told you that these are the 5 steps that you go through to do hypothesis testing. Step 1, state the hypotheses and identify the claim. We did some examples of that last time, so hopefully you remember how that works. Step 2, compute the test value. And step 3, find the p-value. I didn't say much about those last time, so that's what I'm going to explain more about now. And there are different ways you can do that depending on what technology you have available. So I'll describe a few different methods and you can decide which one you want to use based on what you have available and what seems easiest to you. Then step 4 and step 5 we talked about last time. Make the decision to reject or not reject the null hypothesis, and then summarize the results. So what I still have to explain is steps 2 and 3. And one method is if you have a graphing calculator, like some version of a TI-83 or a TI-84, or possibly an app that works like one of those. Now, here I've got the instructions, the steps that you go through on the screen. I'm not going to read them to you. You have them in your notes. But when we go through some example problems, I will show you how this works. So one of the ways you can get the test statistic and the p-value is by using the special built-in capabilities of a graphing calculator. Another method you can use is I have put together an Excel spreadsheet that you can download from Canvas and just fill in the appropriate values. Just put in a few numbers into the spreadsheet and it will give you what you need. So that's an Excel spreadsheet that you can download from Canvas, and that also I will show you how that works when we work through some examples. There are also other apps and software out there that you could use instead that work different ways. I've included instructions about a couple of those in the notes. And if you don't have any advanced technology available at all, you can do this kind of by hand using the tables that we've been using before. So you'd be using table E for the z-test. And you would calculate z using the formula z equals x bar minus mu over sigma divided by the square root of n. We've used that formula before. You saw it in section 6.3. When you put that into your calculator, be sure you use parentheses around the numerator and around the denominator. And whatever number the calculator gives you, you're going to want to round that to 2 places after the decimal point. So that will be what step 2 asks you to find, the test value. Then step 3 asks you for the p-value. So to find that, you have to take the z that you calculated and look it up on table E. And if you're doing a left-tailed test, that is, if your alternative hypothesis has mu being less than some number, then that's the easiest. Then you just take whatever number you get from the table, and that is your p-value. If you're doing a right-tailed test, the number you get from the table, you have to subtract that from 1, and that gives you your p-value. And if you're doing a two-tailed test, you have to double the number that you get from the table. And that also, I will show you at least one example of how that works. So let's work through a couple examples. A certain brand of frozen pizza maker claims they put an average of 10 pepperoni slices on their pepperoni pizzas. The population standard deviation is 1.4. You buy 50 of their pepperoni pizzas and find that in your sample, the mean number of pepperoni slices per pizza is 9.2. At alpha equals 0.01, what does this say about the pizza maker's claim? Okay, so we're going to work through the 5 steps. Step 1, state the hypotheses and identify the claim. Well, right here it says the pizza maker claims they put an average of 10 pepperoni slices on their pepperoni pizzas. So their claim is that the average number of pepperoni slices per pizza is 10. So here's how we'd write that. Mu equals 10. Now, is that the null hypothesis or is that the alternative hypothesis? Keep in mind the null hypothesis is always going to have an equal sign in it, but the alternative hypothesis will not. Because this has an equal sign, this is the null hypothesis. Remember, H sub 0 is the symbol that stands for the null hypothesis. Then the alternative hypothesis would be that mu is not equal to 10. Either it is or it isn't. Either the average number of pepperoni slices per pizza is 10 or it's not 10. It's something other than 10. And there's nothing in the problem about it specifically being less than 10 or more than 10. It's just the pizza maker claims that it's 10, and that's either true or it's false. It either is 10 or it's not. Okay, so that was step 1. Now for step 2, we compute the test value. So we need to know the sample mean. See right here, it says the mean number of pepperoni slices per pizza in that sample of 50 that you bought. You bought some to test, and that sample had a mean of 9.2. So that is X bar. That's the sample mean. The population standard deviation is 1.4. They told you that. The sample size is, so that's how many, in this case, how many pizzas were in your sample. That was 50. And the number that you used in the hypotheses, the number that the null hypothesis said that mu was equal to, remember what that was? 10. Now, no matter what method you use to compute the test value, you do need to use these four numbers. You need to know what these four numbers are. So now we use them to find the test statistic. So let me show you how that works. If you have a graphing calculator and you want to use it, here's how that works. Push the stat button and then use the arrow buttons to go over to tests. And what we want is the very first thing on the list, z-test. So I'm just going to hit enter. Now, right now this is on data, but I want it to be on stats. So I'm going to move over here and select stats. Now it has a place for me to put in values for these four numbers. They're in a different order than what I have them here. So the first one, mu0, that is the 10. That was the number in the hypotheses that we were comparing mu to. The sigma was 1.4. The x bar, 9.2. And the n, 50. The other thing we need to do is down here on this line, we need to select which one of these our alternative hypothesis looks like. If you remember when we wrote down the alternative hypothesis, that was that mu was not equal to 10. So we do want the one with the does not equal sign. Not one of the others, but this one. So make sure that's selected. And then go down here to calculate, or you could select draw, and you might want to play around with that and see what that looks like. But I'm just going to hit calculate, and it tells me, well, there's my alternative hypothesis. Mu does not equal 10. And right below that is the test value. Z equals negative 4.04. It also gives me the p-value, but that's step 3, so we'll come back to that in a minute. The other way you can do this, well, one other way you can do this is, if you go on Canvas, I have posted something called p-value calculator for Excel. So you can download that and open it up. Might have to hit enable editing. And you'll notice down at the bottom here, there are a few different tabs. Right now, we want to be in the one that says z-test. So I'm going to click on that. And I'm going to fill in the appropriate numbers in these 4 yellow boxes. So mu0, the number in the hypotheses, was 10. Sigma, the population standard deviation, was 1.4. X bar, the sample mean, was 9.2. And n, the sample size, was 50. And once I've got those numbers put in, look down here. It says the test value z equals negative 4.04. And then below that, it tells me what the test value is, or what the p-value is, but we will come back to that in a little while. Now I'm starting to run out of time here, so I'm going to stop this video right here. Make sure you immediately go to part 2 so that we can finish this up, go through the rest of this example. See you then.